Hey guys, so based on some questions that you guys have had over this checkpoint, I thought it might be helpful for me to do a video showing how to do finding probability of events checkpoint number 2. It shouldn't take too long. It's only 16 questions, and some of them are fairly straightforward. So we can just get started with it. A fair coin is tossed 12 times. Which of the following outcomes, 1, 2, 3, or 4, is most likely? Well, really the only thing that you have to know about this question is that it's an idea of a fair coin being tossed 12 times. So any combination of the heads or tails is actually going to be equally likely. The probability of a heads is 1/2, and the probability of a tails is 1/2. So this would just be 1/2 times 1/2 times 1/2 times 1/2 times 1/2 times 1/2, 1/2 to the 12th power. But actually, it's 1/2 to the 12th power for all 4 of them. So they're actually all equally likely. In a population, 8% of males have had a kidney stone. Suppose a medical researcher randomly selects 2 males from a large population. Let A represent the event the first male has had a kidney stone. Let B represent the event the second male has had a kidney stone. True or false? A and B are independent events. I'm going to go ahead and say yes, that is true, because one individual having kidney stones really isn't going to affect anything about another male, or anybody else for that matter, having another kidney stone, especially when it says a large population. For safety reasons, 3 different alarm systems were installed in the vault containing the safety deposit boxes at a Beverly Hills bank. Each of the 3 systems detects theft with a probability of 0.87 independently of the others. The bank obviously is interested in the probability that when a theft occurs, at least one of the 3 systems will detect it. What is the probability that when a theft occurs, at least one of the 3 systems will detect it? Okay, so to find the probability of at least one of the 3 systems detecting it, one of the nice things about probability is that we are interested in the probability of at least one detect. Well, sometimes, or oftentimes, that one's a little bit more, I can't talk. This probability is a little hard to detect, or a little hard to find. So what we can do is think about the complement, where what is the complement of at least one event occurring? So that's going to be 1 minus the probability that there are no detections for all 3 of them. So, I didn't need an equal sign. So we just have to look at what we're given and say, okay, each of the systems detects theft with a probability of 0.87 independently of the others. That's important. So if there's a 0.87% chance that one of the systems will detect something, that means there's a 0.13 event, or a 0.13 probability that it will not detect. So to find this probability, we're going to say, all right, well, the probability that one system does not detect is 1 minus 0.87. Well, we're looking for none of the systems detecting it. So that means that we're looking for all 3 to not detect. So that means the first system's going to fail, the second system's going to fail, and the third. And because these occur independently, or because these detections are independently, we can just multiply all 3 of those together, giving us 0.99780. 1, 2, 3, 4, 5. Remember, in Excel, if you don't remember how to adjust your decimals, just go to this feature here. In a certain level arts college with about 10,000 students, 45% are males. If 2 students from this college are selected at random, what is the probability that they are of the same gender? So, we need to think about this question in terms of the probability of same gender is the probability of both male or both female. Let's say or both female. Now, because this is a large population, when we select one male, that really isn't going to affect the probability of another male getting picked. That's the whole point about them saying 10,000 students. So we can assume independence for this question. So think about our male formula, or not male, think about our OR formula. This means this is the probability of both male plus the probability of both female minus the probability of, their intersection. Well, being, in this case, getting 2 male and 2 female, if we're only selecting 2 students, can't happen. They're mutually exclusive events. So you can just look and see, all right, what's the probability then of 2 male, 2 female? That's an equal sign in front again. I did. So, what we're going to do is this. There's a 45% chance of getting a male, so 0.45. Because we're selecting from a large population, we can assume independence. So we're going to say, all right, this is probably, really close to a 45% chance of another male. And because they're independent, we're just going to multiply. Then we're going to do plus 1 minus 0.45 squared for the probability of getting 2 females. 4 decimal places means we should extend this out one more time. 0.5050. According to the information that comes with a certain prescription drug, when taking this drug, there is a 20% chance of experiencing nausea and a 47% chance of experiencing decreased sexual drive. The information also states that there is an 11% chance of experiencing both side effects. So what is the probability of experiencing only nausea? Meaning, we don't want any decreased sexual drive. We just want nausea. So what it says is that there's a 20% chance of experiencing nausea. Let me see if I can get a Venn diagram. Hold on. I couldn't get a Venn diagram. So we're just going to look at it like this. We want only nausea to occur. So the probability of only nausea is going to be the probability of nausea in general. I know that sounds a little bit weird because it sounds redundant. But this probability here, where it talks about the probability of nausea, that's including the intersection of nausea and experiencing sexual drive. Basically, experiencing both situations at the same time. So, if we want only nausea, that means we just have to subtract away what is the chance of also experiencing a decreased sexual drive. In addition, simultaneously experiencing nausea. So we take the probability of nausea and subtract away the probability of both. So that means the probability of experiencing nausea is 20% or 0.2, but we also have an 11% chance of experiencing a decreased sexual drive as well, but we don't want that included, so we subtract that away. So it's 0.09. According to the information that comes with a certain prescription drug, when taking this drug, there is a 17% chance of experiencing nausea and a 53% chance of experiencing decreased sexual drive. There's also an 11% chance of experiencing both. What is the probability of experiencing neither of these side effects? Well, neither of these side effects means that we don't want nausea, nor do we want, so no nausea. I can't spell nausea. Let me spell it, this looks weird. I guess I can type it in. N-A-U. No nausea or no decreased sexual drive. I'll just call it that. Well, thinking of the complement rule, this can say we want neither of the side effects. So this is going to be 1 minus the probability of nausea or decreased sexual drive. And so we know then 1 minus, we can use our rule for OR probability to figure this out. This is going to be the probability of nausea, which is 17%, plus the probability of experiencing decreased sexual drive. But we also have to consider the fact that they can occur at the same time. So we subtract away their intersection. So no nausea or no decreased sexual drive, that's neither event. So it's going to be 1 minus the probability of nausea or a decreased sexual drive, and then we're just using that formula for OR. And I should probably put an equal sign in front of that. 0.41. Oh, another one. Okay. According to the information that comes with a certain drug, 20% chance nausea, 47% chance of decreased sexual drive, and 10% chance of experiencing both. What is the probability of experiencing nausea or a decrease in sexual drive? Well, we've already found that. Probability of nausea or decreased sexual drive. I'll just do it again just so you can see it. This is going to be the probability of nausea plus the probability of a decreased sexual drive minus the probability that both happen. And we're given everything we need for this. We're given the fact that nausea has a probability of 20%. Decreased sexual drive has a probability of 0.47, and it occurs together 10% of the time. So 0.57. Not 58757. Alright, an engineering school reports that 56% of its students are male, 35% of its students are between the ages of 18 and 20, and that 28% are both male and between the ages of 18 and 20. What is the probability of a random student being chosen who is female and is not between the ages of 18 and 20? Right. So we want the probability of being female and not between the ages of 18 and 20. So what we can do for this is that we can just say this is equal to, we want the probability of female and not 18 and 20. Well, this can be thought of as the probability, 1 minus the probability of not male or 18 and 20. So if you're female and not 18 to 20, that's going to be 1 minus the probability of male, not male, of male. Where is it? Or 18 and 20. We don't want it to be male or 18 or 20, because if we're not male, that implies we're female, and if we're not 18 or 20, well, then that's what we're trying to find. And we have all the information given to us in the problem. 1 minus, the probability of being male is 0.56. The probability of being 18 and 20 is 0.35, and subtract the probability of both, 0.28. 0.37. Oh, I saved. Yeah, make sure when you do these assignments that you save every once in a while. Okay, an engineering school reports that 57% of students are male, 39%, okay. What is the probability of choosing a random student who is female or between the ages of 18 and 20? So we want, this is a little different. We want probably a female or 18 to 20. Well, that's going to be the probability of female plus the probability of being 18 to 20 minus the probability of being both female and 18 and 20. So we're not given everything that we need for this problem first. We need to find that ourselves. We need the probability of female, the probability of 18 and 20, and the probability of being female and 18, 20. So the probability of female is just going to be 1 minus the probability of being a male. Okay? The probability of being 18 to 20, 39% of the students, alright, 0.39. We're given that. And then we need to find the probability of being female and between the ages of 18 and 20. Well, really easily, that's just going to be the probability of being 18 to 20 minus the probability of being a male. Or actually, let's see. Engineering school, 15% of students are between the ages. So that's just going to be the probability of being 18 and 20, which we're given is 0.39. But this number, if you think about the way these are calculated, or what these mean, the probability of being 18 and 20 includes just both males and females together. Out of all the students, there's a 39% chance of being 18 and 20, male or female. So if we want a probability of being female and between the ages of 18 and 20, we just have to take that probability of being 18 and 20 and subtracting away their intersection. So that's 0.24. Subtract away the probability of being male and 18 and 20, and now you get the probability of being female in 18 and 20. So that tells us then to find our probability, we're just going to do 0.43 plus 18 and 20 and subtracting their intersection, 0.67. All right. My alarm. An engineering school report, same thing. Okay. What is the probability of a random student being male or between the ages of 18 and 20? Well, that's really easy because that gives us everything we need. Probability of being male or 18 and 20 is the probability of male minus the probability plus the probability of 18 to 20 minus the probability of being both, which fortunately for us, they give us everything. The probability of male is 0.55 plus the probability of 18 and 20 is 0.38 minus their intersection, 0.21, 0.72. All right. Let A and B be two independent events such that the probability of A is 0.48 and probability of B is 0.32. What is the probability of A or B? Well, same thing as these word problems up here. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of both A and B. I'll write it down. Well, the key word in this problem is independent. Because we know that when two events are independent, the probability of A and B is just their product. Okay, I don't know what happened. Hello? Equal sign. So, that's all we need. So, because they're independent, we know the probability of A and B is the probability of A times the probability of B. Please make sure, though, that when you do these types of problems, you look for that word independent. Because if they're not independent, you cannot break up this probability into the product. So all we have to do now is just say, all right, probability of A is 0.48, probability of B is 0.32, minus their product. And we want 4 decimal places, 0.6464. Next one is A and B. Well, easy. Same idea, but now we just want A and B, which we know from the question before, because they're independent, the probability of A and B is 0.2 times 0.7, 0.14. Let A and B be two disjoint events. Disjoint just means mutually exclusive. It means the events cannot occur simultaneously at the same time, which means that by definition, the probability of A and B is just automatically 0 because they're disjoint. So in this case, A or B, which is typically probability of A plus the probability of B, if they're disjoint, that means the probability of A and B is just 0. So all we have to do is add the probabilities together. So that's going to be 0.59 plus 0.03. 0.62. So the only thing that differs here is that we're using the word disjoint, which means A and B, the probability of that occurring is 0. Same thing with this next question. What is probability A or B? Well, that's just the probability of A plus the probability of B. Because when you subtract away their intersection, you're subtracting 0. All right, question 15. Okay, we have a probability distribution, probability being underweight 0.02, probability being healthy weight, okay? What is the probability that a random sex U.S. adult is not obese? Well, the probability of not obese is just 1 minus the probability of being obese. Which if you look at the table, they tell us the probability of being obese is 0.251. 3 decimal places, 0.749. All right, the probabilities for the amount that can be won on the lottery game are given in the table below. Find the missing probability X. Well, one of the things to know is that in a probability distribution, all of the probabilities have to add up to 1. So here are all 5 of your events. Their respective probabilities need to add up to 1. So all we have to do is just say, to find the missing probability, just do 1 minus this, minus the other ones, minus this one and minus this one. I'm just clicking on the numbers, and we get 0.16. And notice, if I replace x with 0.16, if I highlight all these numbers, look at the bottom, it says the average is 0.2, which doesn't matter. There are 5 numbers, and all add up to 1. So let's submit and see what we get. Hopefully it's 100. 94. Let's see. Let's just make sure. What happened? Let A and B. Oh my gosh, I did what I said I would never do. Oh! I wasn't paying attention. This is a trick. Let A and B be 2 disjoint events. I didn't read the question, and I'm so sorry. Let A and B be 2 disjoint events such that the probability of A is 0.59 and the probability of B is 0.03. I read that as OR. What is the probability of A and B? Remember what I said. This number, if the 2 events are disjoint, is automatically 0. So the answer to question 13 should have been 0. I didn't even read it. I'm sorry. I just saw this one and assumed. So this one's really easy. There's no computation necessary. This is just definition of disjoint events. The probability of A or B is 0.62. Other than that, everything else should be right. Yeah. So I'm sorry about that one question. It's early. I got up early to do this. So hopefully this helps you guys. And as always, if you need extra help, please email us. We're all here to help you. Have a good one.